Okay, this is part 2 of that section 4 factoring notes. And in part 1, just a reminder, we had talked about factoring out a GCF to factor polynomials. We had talked about factoring a trinomial, but only in a special case, only when a was 1, so x squared didn't have a number in front of it. And then we also talked about combining those two methods to factor. So let's look at specifically a third method here, factoring the trinomials. Remember, that means 3 terms. When a is greater than 1. So that means our x squared is going to have a number in front of it. In that first example, 6. Now, these problems definitely become harder. They're more challenging when it's not 1. But we're still going to use the box method. We're still going to use that box method, and it's going to work fine, just like we would with a being 1. So in the box method, if we look at setting up our box, we know in the top left is 6x squared. In the bottom right is 6. Those numbers come from here. Now remember, we need a times c. Before a was always 1, but this time a times c, or the first times the last term, is 36. We need to list out multiples of 36 that add to 37. Well, I think that one's just going to be 1 and 36, right? Because 1 plus 36 is 37. So let's go ahead and put 36x and 1x in those boxes, factor out the rows and columns. So, from the first row, I'm going to pull out a 6x. The GCF is 6x. From the second row, just 1. From the first column, it looks like just x. From the second column, a 6. So my factors, 6x plus 1 and x plus 6. Remember, if I multiply this out, I get the original polynomial. I can always check it that way. I get the original polynomial if I multiply those factors out. Okay, let's look at another example here. Again, a is greater than 1. It's a trinomial, so we're going to use the box method again. The first term goes up here. The last term goes here. And we need a times c, so 2 times negative 3. List those multiples. Those multiples have to add to give me negative 5. So I think the ones I want, if I think about the multiples of 6, I'm going to end up doing, one has to be positive, one has to be negative to get to negative 6. So I'm going to end up doing 1 and negative 6. Because if I add those together, I get negative 5. So let me put my x in my negative 6x, and let's factor out rows and columns. First row, x. Second row, negative 3. Whoops. There we go. First column, I'm going to take out a 2x. Second column, we'll just take out 1. That means my factors are x minus 3, 2x plus 1. Okay, look at the third example. Again, a trinomial, a is greater than 1. Box method. 12x squared and 6. Well, 12 and 6, or a times c, is the number we need. 12 times 6 is 72. A little bit bigger number. We need those factors that add up to 17. So you think about factors of 72, you can list them all out, but the one we're looking for is 8 times 9, because 8 times 9 will give us a sum of 17. So I'm going to put 8x and 9x and do my GCF of this box method. So let me move this over a little bit more. First row, I can take a 3 and an x out. Second row, I'm going to pull a 2 out. Column, I can take 4x out. And then the last, I'm going to pull a 3 out. So 3x plus 2. 4x plus 3. And our last example I want to go through with these trinomials of a greater than 1. Again, 3 terms, trinomial, tells you box method. 4x squared, and then a positive 1. I don't need to put a plus 1. I can just put 1. A times c. Well, 4 times 1 is just 4. Let's get those multiples of 4 that add to negative 4. Well, there's only 2 choices here. Now, we know they both have to be negative. So which one of those adds to negative 4? Definitely this one. So I'm going to split up negative 4x into that negative 2x and negative 2x. Do my GCF. Whoops. I have 2x. On this one, remember, if the first term's negative, we want to factor that out. So negative 1. Here, 2x. Again. Now my pen's dying on me again. 2x. And here, if the first term's negative, we want to factor that out. So negative 1. My factors are the same. 2x minus 1, 2x minus 1. A lot of the times you'll see that also written as 2x minus 1 squared because they appear twice. So either one I'd accept, but sometimes people shorthand it like that. So go ahead and finish the second video for these notes. That should be over difference of squares and then sum and difference of cubes.